Uranus, the ice giant. This cold, grayish-blue planet seems like a desolate expanse in the far reaches of the solar system. But in reality, there are some fascinating facts about this planet that make it unique in the solar system. Stay with me on this journey, and we'll explore everything you might want to know about Uranus. Remember to subscribe to the channel and hit the bell for new content. The first unique aspect of Uranus is its name. All the planets are named after Roman gods, except for this giant, which is named after the Greek god of the sky, Uranus. Uranus is also very special in how it rotates and orbits. It is the seventh planet from the Sun, the penultimate before Neptune, and it orbits at an average distance of about 19.2 astronomical units from the Sun, which means it is over 19 times farther from the Sun than Earth. This distance varies over the year by 1.8 astronomical units, the largest orbital variation of any planet. Being so far from the Sun means it is extremely cold. In the upper atmosphere, the temperature hovers around -220 degrees Celsius, making it the coldest planet in the solar system. Its year lasts 84 Earth years. When it was first observed, astronomers predicted its orbit. After some time, however, they realized it did not follow their predictions and concluded that the reason was the gravitational influence of another planet, which led to the discovery of Neptune. Interestingly, a similar theory surrounds the so-called Planet X. Some distant objects in our solar system are not where they should be, and the theory suggests this is due to another planet at the edges of the solar system exerting a gravitational influence on them. The hunt is now on to find this planet. Now, the really interesting thing about Uranus is its rotation. Imagine the solar system laid out on a plane. Most planets rotate like a top on this plane, but not Uranus. Instead, Uranus rolls on the plane. Its axial tilt is 97 degrees, meaning its seasons are bizarre compared to the other planets. During its solstice, one side of the planet is always facing the sun, while the other is in complete darkness. Only a very narrow strip near the equator experiences day and night during this period. The poles get 42 years of continuous darkness followed by 42 years of daylight. During its equinox, the planet has a more normal day-night cycle. Uranus rotates once every 17 hours and 15 minutes. Since its surface is not solid, some parts of the atmosphere rotate faster than others. Due to strong winds, some parts can complete a full rotation of the planet in just 14 hours. This strange rotation means it is the only planet that, on average, receives more energy from the sun at its poles than at its equator. For some reason, though, the equator is warmer than the poles, and no one really knows why. There is also speculation about why Uranus rotates in such a bizarre way. It is generally accepted that a large Earth-sized planet crashed into Uranus, knocking its rotation onto its side. How big is Uranus? It is the least massive of the gas giants, with 14.5 Earth masses compared to Neptune's 17 Earth masses. Its diameter is just slightly larger than Neptune's, at about 5,700 km, about 4 times that of Earth. Because this mass is distributed, the gravity on Uranus is only slightly lower than on Earth, at 8.7 meters per second squared, or 0.89 g. What is Uranus made of? It has a smaller silicate rocky core than Earth at its center, surrounded by a mantle of water, ammonia, and methane ices. Although referred to as ice, this mantle is actually very hot, reaching nearly 5,000 degrees Celsius and is more like a liquid ocean surrounding the core. The atmosphere, by comparison, is very insubstantial, comprising only a total of 0.5 Earth masses. Most of Uranus's mass is in the core and mantle. The atmosphere is primarily composed of helium, hydrogen, and 2.3% methane. It is this methane that gives Uranus its aquamarine color. Interestingly, some models suggest that the pressure at the base of Uranus's mantle is sufficient to break methane molecules, compressing carbon atoms into diamonds. These diamonds rain through the mantle like hailstones. Incredibly, the base of the mantle itself may be a layer of liquid diamond with diamond icebergs floating within it. Uranus, like the other large planets in our solar system, has rings. It has 13 very dark young rings. Most are no more than a few kilometers wide and are thought to be only 600 million years old, much younger than Uranus. They are composed of extremely small particles, the largest of which is only a few meters wide, made of water ice and dark radiation-processed inorganic materials. Their albedo does not exceed 2%, or in other words, their reflected light is darker than damp ground on Earth. As we will see shortly, Uranus has many moons, and it is thought that the rings are the result of high-impact collisions of some moons in the past. It is unclear why some of the rings are so narrow. The usual explanation is that the rings are kept in line by shepherd moons, but this is the case for only one of the rings. Uranus was first discovered to have rings in 1977 during the occultation of a star. Uranus has only been visited by a probe once in 1986 by Voyager 2, which discovered many of Uranus's rings and moons, giving us close-up shots of the faint ring systems and discovering 11. When Hubble was launched in 1990, it took a look at Uranus, discovering 2 additional rings that had never been seen before. The outermost ring is twice as far from Uranus as the outermost ring we previously knew. And as promised, here's a look at the many moons. Unusually, the moons are named after figures from English literature. In total, Uranus has 27 known moons, divided into 3 categories: the 13 inner moons, the 5 major moons, and the 9 irregular moons. The inner moons are connected to Uranus's rings, some of which may have provided the ring materials. The largest of these moons is called Puck, with a diameter of only 162 km, and is the only inner moon to be captured in detail by Voyager 2. Interestingly, these inner moons constantly perturb each other and the system seems very unstable. There is a good chance that some of them may collide again in the future. The 5 major moons, in order of distance from Uranus, are Miranda, Ariel, Umbriel, Titania, and Oberon. Titania is Uranus's largest moon and the 8th largest moon in the solar system, with a diameter of 600 km. Again, these are very dark objects. Umbriel is the darkest, with the exception of Miranda, which is mostly composed of water ice. The rest are thought to be a mix of water and rocky materials. These moons may have differentiated interiors, with a core of rocky material and a mantle of ice. Between the core and mantle, there could be a layer of liquid water. Interestingly, the axial tilt of the large moons is the same as Uranus, meaning that during the solstice, if you looked at the sun, it would move in a circle in the sky without ever setting. During the solstice, only one side of the moon faces the sun, meaning constant daylight. The last 9 known moons are irregular moons, likely objects captured by Uranus, and are much farther from the last of the major moons, Oberon. They vary in size, starting from 20 km to the largest, Sycorax, which has a diameter of about 200 km. Finally, let's explore the climate and magnetosphere of Uranus. Uranus's seasons are quite unique in the solar system due to its extreme axial tilt. However, we only have data for about 1 Uranian year, making it difficult to say for sure the differences between the years. What has been observed is that as the planet approaches the solstice, the pole brightens and a collar forms. Moving away from the solstice, the collar dims. This brightness is thought to be due to the thickening of methane clouds, though the cause is unclear. The seasons also affect storms in the upper atmosphere. Storms are relatively rare on Uranus compared to other gas planets, but are thought to be caused by seasonal changes. Another unique feature of Uranus is its unusual magnetosphere. Usually the magnetosphere originates from the geometric center of the planet, but this is not the case for Uranus. Additionally, it is not aligned with the rotation axis but is tilted by 59 degrees. This unusual position means that the magnetosphere is much stronger at the North Pole than at the South. One theory is that the ocean of liquid diamonds may deflect the magnetosphere, or that it is not the core of the planet producing the magnetosphere, but rather the water mantle. The magnetosphere is as strong as Earth's, and due to its unusual rotation, the magnetic tail extends millions of kilometers into space. Thank you so much for watching. I hope you have learned more about this rather mysterious planet. Remember to leave a like to support and subscribe to the channel.